Okay, welcome back. This is video number 3 for Unit 2. So we just finished up talking about some general formulas for accelerated motion and some specific formulas for accelerated motion when the initial velocity is 0. So in general, these are the formulas on the left that we will use. The top one relates velocity, final, and time. The middle one, distance and time. The last one, velocity with time. Off to the right, we have the specific versions when the motion is starting at rest. So in example 1, a ball is dropped from a 180 meter high building. First thing we should probably do is figure out what we're talking about here. A ball is dropped. This tells me that initial velocity equals 0. From a 180 meter high building, that's distance. Part A, find its velocity after 3 seconds. So we're looking for velocity. This will be VF really. After 3 seconds, and that's T. So we need to find a formula that relates velocity and time. And so we look back up here, velocity and time, with the specific instance of we're starting at rest. So final velocity equals the acceleration times the time. I'll write out the general formula here so we can see it completely. Final velocity equals initial velocity plus the acceleration times the time. Final velocity equals 0 plus the acceleration, which is a falling object. The acceleration is gravity, negative 10 meters per second squared, times the time, which is 3 seconds. And so the final velocity here is negative 30 meters per second. As far as our units go, seconds will cancel with seconds squared and leaves us meters per second. So you could also say that its velocity is .30 meters per second down. How far has it fallen after 4 seconds? So in this one, how far, that's distance, has it fallen after T, 4 seconds? And there are really 2 methods that you could do here. Method 1 uses our physics formula that we see at the top. We are trying to relate distance and time. So we look up to our formulas, the one that relates distance and time. Distance equals initial velocity times the time, plus 1/2 the acceleration times the square of the time. So we can fill in some numbers. Distance equals 0 times 4 seconds plus 1/2 times negative 10 meters per second squared is our gravity, and time is 4 seconds. Probably the biggest thing that students forget to do is squaring the time. Don't forget to square the time. So we can simplify this some. So this is distance equals, that's 0, plus 1/2 times 10 times 4 squared. And so, really don't need to write the 0 plus. It is negative 80 meters. This is how far it has fallen. Negative 80 meters means it has fallen 80 meters down. The other possibility, method 2 is distance equals rate times time. And this works because the acceleration of gravity is uniform acceleration. So distance equals rate would be the average velocity based on uniform acceleration. So our final velocity after 4 seconds. So let's figure out what this is. So let's draw a little something along the margin here. Time, velocity, and this is going to be a ball that's falling. So this is going to be at time 0, its velocity is 0. Here's the ball. Time 1 second, it is now moving at negative 10 meters per second, and here's the ball. Time of 2 seconds, negative 20 meters per second, and here's the ball. Time of 3 seconds, negative 30 meters per second, here's the ball. Time of 4 seconds, negative 40 meters per second, and the ball is down here. And so on. Maybe our 5 is here. So you see that close, getting farther, getting farther, getting farther, and getting farther. So after 4 seconds, it is negative 40 meters per second. So we can consider that the final velocity plus the initial velocity of a dropped object is 0 divided by 2. This is the average speed of the ball over this entire 4 seconds. And then multiply that by 4 seconds. And you get the same answer. Distance equals negative 40 divided by 2 is 20 times 4, negative 80 meters per second. Really, the best bet is to use method 1 with our distance and time formula. That would be the best way to go about this problem. But the method 2 does work once you get a good hang of it. Example C, how far does it fall in the 3rd second? So before we jump into this, we need to define what is the 3rd second. So we have a time of 0, 1, 2, and 3, and 4, and so on. This is the 1st second. From 1 to 2 is the 2nd second. And from 2 to 3 is the 3rd second. So we are talking about time equals 2 seconds to time equals 3 seconds. How far does it fall over this period of time? So we're looking for how far, that's distance, and we're talking about time. So we're going to use the formula that relates distance and time. Distance equals initial velocity times the time plus 1/2 the acceleration times the time squared. And plugging in our numbers. So distance equals the initial velocity. So we're still talking about the same dropped object. So 0 at 1 second is negative 10, at 2 seconds it's negative 20. So our initial velocity here is negative 20 meters per second. This time period from 2 to 3 is 1 second plus 1/2. A is the acceleration of gravity, negative 10 meters per second squared, and then the square of the time. The time again is 1 second, and we have to square it. So solving for this, we have distance equals, so this is negative 20 meters. Seconds cancels out here, and seconds squared cancels out here. So this gives us minus 5, let's keep it the same, plus negative 5, plus negative 5 meters. And so during this third second, it falls 25 meters. And we don't really have to specify that it falls 25 meters down. Falls, to some degree, indicates a direction. Things fall downward, things do not fall upward. Again, you could use method 2, distance equals rate times time. So distance equals our average velocity over the interval. So our final velocity is negative 30. Add that to our initial velocity, negative 20. Divide those by 2 gives us the average velocity, and it's over a time of 1 second. So distance equals negative 50 divided by 2, which is negative 25 meters. Seconds will cancel. And it works. How long will it take to reach the ground? So remember, we are dropping this object. How long will it take to hit the ground? That's time. To reach the ground, the top of the building is 180 meters. If it hits the ground, that means the distance was 180 meters. So for this one, we are using our distance formula. It relates distance and time. Distance equals initial velocity times the time plus 1/2 acceleration times the square of the time. There's the formula. So how long? Plugging in our numbers. Distance is 180 meters. Really, we should be more specific. It's falling 180 meters. So distance is negative 180 meters. Remember, negative means down. It is falling, which means it is traveling negative distance. Initial velocity of a dropped object is 0. Plus 1/2 times the acceleration is negative 10 meters per second squared. And we are looking for the time. So here we have t squared. So negative 180 equals negative 5 meters per second squared times t squared. Divide both sides by negative 5, and we end up with 36 seconds squared equals t squared, and time equals 6 seconds. So I've got a note here, distance is down, and it should be negative, but be careful to avoid taking the square root of a negative number. So be careful when you're looking at square roots and negatives being down. How fast is it going after falling 80 meters? How fast, final velocity, and falling 80 meters is distance. So the formula that relates velocity and distance, if you look back up the page, is final velocity squared equals initial velocity squared plus twice the acceleration times the distance. So filling in the things we know, initial velocity of a dropped object is 0, plus 2, acceleration of gravity has been the same the whole time, negative 10 meters per second squared, and our distance is negative 80 meters because it is going down. It is negative. So final velocity squared equals 1,600 meters. Taking the square root of that, that was meters squared per second squared, excuse me. Taking the square root of all of this, we get 40 meters per second. Is its velocity down. Now again, you're going to have to pay attention to the direction, the positive and negative, because its final velocity is in the direction of the ground, which would be negative, and so we need to be careful. How fast is it going as it hits the ground? How fast is it going as it hits the ground? So we know that it hits the ground after a distance of 180 meters. How fast is final velocity? So we need a formula that relates final velocity and distance. Final velocity squared equals initial velocity squared plus twice the acceleration times the distance. So filling in the things that we know, initial velocity of a dropped object is 0, plus 2 times the acceleration of gravity, negative 10 meters per second squared. And the distance here is negative 180 meters. Final velocity squared equals 3,600 meters squared per second squared. Square root of that tells us that the final velocity is 60 meters per second down. Or negative 60 meters per second.